stuck, format it, touch it, bring it, pay, watch it, turn it, leave it, stuck, format it.
Let's go. All right, class, welcome back. Today we're going to talk about how to solve a line of best fit, um, week 4, marking period 2. Let's jump into the material. Full screen. Okay. All right, so in this question right here, this is going to come back. You guys are going to see this in the answer key for the homework. So we're going to drive on. All right, you guys, this word bank, I didn't think it was super difficult, but I do want you to remember correlations is a relationship. Correlation coefficient is a number. Okay? So again, correlation is a relationship between two sets of data, but a correlation coefficient is a number from -1 to 1 that says how strong the dependence relationship is. So again, I told you about the idea of do you want something that's closer to $1 or closer to a nickel? We'll talk more about that. All right, here we see no pattern at all, no connection at all. This is no correlation. Here we see a pattern where as I go from left to right, my data is going up. So we say this is a positive correlation. As I go increase in the X value, my Y values are increasing. Here, as I go from left to right, I notice my data points are going down. So we call this a negative correlation. Negative correlation. All right. All right, here we are. We're looking at a situation where the museum over the course of years is steadily increasing the amount of attendees that it has. 2007, 8.3 million. 2013, 9.3 million. So we see a constant influx of attendees. So what we need to do there is we need to basically remember they're asking us to change 2007 to 0. 2008 must become 1 because I'm increased by a year. 2009 becomes 2. 2011 becomes 4, so forth and so on. I'm gonna pause the video. Now let's take a look. Once I get this in my calculator, all right, what I want to do is I want to take advantage of the diagnostic, the correlation button. And so what I'm doing basically is I'm hitting mode, and mode's going to take me to this screen right here. And it says statistical diagnostic. When you have your calculator and we do our our second plus 712, it wipes out the memory, you reset it. This automatically kicks that our linear regression coefficient, turns it off. So we got to actually go back in and turn it on. And again, the easiest way to do that, guys, is you bring up your graphing calculator, turn it on, and you hit mode, scroll up, and there it is. Okay, there it is. All right, so full screen, let's get it. All right, so we turn it on. What's the next step? After we turn it on, we're going to go through our natural progression of finding the equation of the line. And here we see my equation of the line, if I round it up, should be y equals 0.6x plus 8.27. Okay, but now we have the benefit of getting that coefficient as well, because now it's going to spit it back 0.97, and 4 is going to make me round it down, so that's going to be my final answer. So again, I feel like I explained this pretty well. but I want to make sure that there's no question of what we did. So, first thing we did, as a review, took our numbers, created a table. All right. From that table, I used my statistical feature on my calculator by turning the stat diagnostic on. Okay. Once I get this in, I hit stat calc. I hit number 4. It brings up the equation of the line, but it also brings up my coefficient. And remember, when my coefficient is closer to $1 than it is to a nickel, that means there is a strong correlation. There is a strong relationship between one variable and another. In this case, my variable is the years the museum has been open, and the other variable is the amount of people who attend the museum. All right, let's take a look at our next question. All right, you read it silently as I read it aloud. Bella recorded data and used her graphing calculator to find the equation of the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient, here's my correction, negative 0.9 or 0.8 represents the strongest linear relationship? Now explain your reasoning. Okay, let's go to our last question because I want to keep this under 9 minutes. So first of all, we want to know that if the strategy is always which coefficient is closest to $1, then we got to look at 90 cents and not 80 cents. All right. Now, what happens sometimes is we get confused because of this negative being in front of here, and we almost kind of think about our number line scenario. But I want you to remember, the only thing that negative or that positive denotes, wait for it, the only thing it denotes is if my slope is going up or if my slope is going down. So a negative 0.8 means that my slope is correlated downward. A positive 0.8 means my data is correlated upwards. Okay, so that's all it means. Don't get confused by the by the throw off. And we'll be back shortly with part 2 of the video. And remember, even if Mr. McCrae gives you 20 minutes before a quiz to study, don't get in the habit. The best way of studying for any quiz that I give you is 30 minutes a day. And if you get the 30 minutes a day in, the bad grades will stay away. Always and forever. McCrae out. Peace.